So hey guys, welcome to my first video. So in this video we're going to be covering the basics of vectors. So this video is basically going to be an introduction to vectors for those of you who don't have any clue on what a vector is. So this is the place where you start. So let's get started. Okay, so before we actually go in and see what a vector is in physics or in maths, the first thing that we want to focus on is I'm going to be drawing a few lines over here, so don't mind the arrows for now, and maybe something like that. Maybe I'll extend this all the way there. Okay, so I have a few lines that I've drawn. So what I'm going to do is I'm going to name this line over here X, this line as Y, and this line as Z. Okay, so basically I just have three lines on the board, namely X, Y, and Z. So these three lines are called the three axes. So this is the X axis, this is the Y axis, and this is the Z axis. So the Z axis, you can imagine this line Z is a line that's coming out of the screen towards your face. So this part starting from here until here, that keeps going on. So this part of the line, it's coming out of the screen towards your face, and this part that's behind, it's going into the screen underneath it. So this line, as you can see, it's like horizontal, and this Y line is vertical, but the visualization of the Z line is it's coming out towards your face, and the bottom part is going underneath the book. Okay, so now these three lines are the three axes. So naturally a question arises, what is an axis? Okay, so the term axis, I'm not sure what it's actually called or what the actual definition is, but according to me, an axis is any line about which some change occurs. So regardless of this over here, I can consider this line over here. Let me just draw the arrows, and let's say LM. So I can call line LM to be an axis if there's some change or something is happening around this line. The most basic example would be if I were to take let's say if I were to take this pen over here and I was to place it on the line LM, and if this pen were to rotate like this around LM, or if it were to, if it's starting rotating over here, it's going into the book and coming out. Or if that is too hard to visualize, I'm gonna take, let's say, this cap over here and I place it on top of line LM, and let's say this thing rotates about LM. So what I'm trying to say over here is, if I consider any object, the most basic one would be a square or a rectangle in this case. So what I'm trying to tell you guys over here is, when I have this rectangle over here and this rectangle is rotating and this part stays fixed, it's these parts that move around the line, but this part stays fixed on the line. So with respect to this line LM, this square is rotating. So this line LM happens to be an axis, because about this axis, or with respect to this line, some change is being carried about, or something is being measured. So with respect to this line, you're doing something, or you're considering something happening. So this line LM becomes an axis. So why do I call these three lines to be three axes? Nothing's going to be rotating over here, or nothing's going to be moving, everything's going to be stationary. So then what is happening? Why do we call these three lines to be an axis if there's nothing happening around it? So the reason why we call these three lines to be the X, Y, and Z axis is because with respect to these three lines, we can measure, or we can tell where a point exactly is. Okay, so let's say there's a boy. So the red marker represents a boy. So initially he's at the center of the three lines where they coincide. Okay, he's right there. Okay, so what happens? This guy starts walking. He starts walking along the line X. Okay, so let's say he walks for 5 minutes or whatever, 5 minutes, and he ends up at a point somewhere over here. Again on the line, obviously, because he's traveling on the line. So let's say he traveled a distance of 5 meters. So let me try to quantify this to be 5 meters. So there was a guy who was initially at the point of coincidence of these three lines, and then he walks about the line x 5 meters. So now if I were to ask you, where is this person now? You'd probably say 5 meters, right? Because it's obvious. First he was here, now he's here, he's moved 5 meters, so he's 5 meters away. But if I hadn't given you this condition, or if I hadn't told you that this is where he started from, and now he's only here, and I ask you, how much has he moved? It would be an illogical question. Because since I gave you the starting point and the end point, you were able to tell me the displacement or the distance he covered. You were able to tell me, okay, after 5 minutes, he was 5 meters away on the x-axis or on the line x. But if I hadn't given you this line, I say after some time, a person is over here. Calculate the distance or tell me where he is. You can't give me a proper answer. So for this confusion not to arise, we have the three axes, the x, y and z axis. So the point of coincidence is called the origin. So this point over here is called the origin, and you, in mathematical terms, you represent it by saying 0, 0, 0. So the first digit of this is basically a pair, okay? I'm gonna call, it's not exactly a pair is supposed to be two numbers, but I'm gonna call this a triplet or something, okay? So when I have a triplet, let's say x, y, z, okay? These three are numbers, okay? So the first number will tell you how much distance that point is away from the origin along the line x. Listen to this very carefully. The last part is very important. The first quantity or the first number tells you how far away an object is from the origin, from the point of coincidence along the line x. Okay? So similarly, the y and z, these two numbers tell you how far a person is along the line y and how far a person is along the line z, all with respect to this one point of coincidence. So now if you can see, when I first told you about what an axis was, I said some change happens about the axis. So over here now it's going to make sense, because about the point of coincidence of these three lines, we measure where exactly a point is. So with respect to x, y and z, these three lines, we come to a conclusion that this point or this person is at this place. So since naturally we are doing something with respect to or about these lines naturally become the axis. Okay, so this was a very simple case. The position of this person right now can be given by 5, 0, 0, because this person has traveled 5 units or 5 meters only along the line x. Along y or z he hasn't traveled anything. So we can say the point, or let's say I'm going to call this point P. So I can say the point P where the person is right now can be denoted by this term saying 5, 0, 0. Okay. But now if the person, let's say from here, okay, he says I'm going to travel in the vertical direction, okay, he starts traveling up, and let's say he goes for about 6 meters. I'm going to tell this distance to be 6 meters, and then he reaches a point, let's say Q, okay. So right now the place where the person is at point Q. So now how does the triplet change? What extra number do we add? So first he traveled 5 meters along this line x, and then he travels 6 meters along the line y, that is in the vertical direction. Okay, so now if I ask you to tell me the position of this person or the position of point Q, the only thing that you would alter in the triplet or this number over here, the distance that is traveled along the line x is constant. 5 is constant, because after this point he's traveling a certain amount of distance along the line y, and he's not traveling anymore along x. Or if you're familiar with the concept of parallel lines, this person is no longer traveling in a parallel direction towards the x, and is traveling in a parallel direction only with respect to the line y, or is traveling only along the line y. So this 5 is not going to change, because along line x is traveling only 5 units or 5 meters. What is going to change is the second term or the y, because now he is traveling 6 meters along the line y. So this is going to become 6. So the new number that you're going to get is going to be 5, 6, 0. So what does this triplet represent? The first number tells you how much distance the person is covered along the x. The second number tells you how much the person is covered along the line y, and the last one along z. So this was a slightly more complicated case than the first one. So now imagine this person is standing over here, okay, and he wants to come out of your screen, mobile screen or laptop screen, and he wants to touch your nose. Okay, so this person, there's a person over here. Assume this guy to be a person, okay. So this guy is at the point Q. Now this guy wants to come all the way towards you and touch your nose. So he has to travel in a certain way. Can you visualize what way that is? He has to come outside the screen that you're watching through, and he has to come and touch your nose. So he has to travel some distance and come exactly above towards you, like where the pen is pointing. He has to come towards you, right? So that is what the z-axis is. So if I say you are about 30 centimeters away, correct? You are about like 30 centimeters away from your screen. So this guy has to travel 30 centimeters along this outside the screen to touch your nose. So the distance that he's going to travel along the z-axis will be 30 centimeters in this case, okay. Later on we'll be neglecting the units, I'll teach you that, but for now this makes sense, right? He has to travel some distance along x, that's the first number, some distance along y, that's the second number, and some distance outside the screen, that's along z. So that is the third number. So this is the basics of vectors that you have to learn. So when I say this entire setup is called the Cartesian plane. So this Cartesian plane, let me write that down. So this entire setup, it's called the Cartesian plane, okay. And this point of incidence of the three lines is called the origin, and it's represented by 0, 0, 0, because you're not traveling along any line, you're at the starting point. So now there's not going to be a problem anymore. For example, if I give you a point over here, okay, let's say at 7 meters along y, and I say find the position of this point. Now you immediately will tell me 0, 7, 0, and the question that you asked the first time, asking me what was the starting point, is not going to be in your mind anymore, because we assume that the origin was where he started from. So if I give you any point in and around this place, and if I give you a point here and tell you find the position of this, you just have to assume that there was a person who was initially at this point of coincidence, and then he walks all the way and comes to this point, and we're basically measuring the distance is traveled. So the point of reference, or the point with respect to what we calculate distance or position, is the origin. So now it's going to make quite a bit of sense when I said an axis is a line about which something happens or something is measured. So about these three lines, we are basically measuring the distance or the displacement, or how far or how near a point is. So these three lines naturally become the axis, and this entire setup, as I said, is called the Cartesian plane, and this point of coincidence of the three axes is called the origin. So this is it for the first introduction of vectors. So in the next video we'll be going into the actual concept of vectors and how to represent a vector. So if you have any doubts, do leave them in the comment section below, and I'll get back to you as soon as possible. If you found this helpful, do leave a like and of course subscribe. Thank you guys.